Guys, and welcome to the last video for Unit 1. Cue clapping. So this lesson is all about special angles, and it's the last little tie-in piece that we need to do. So starting off, we see that we have complementary angles versus supplementary angles. So complementary angles are angles that add to 90 degrees. Way that you can remember that is you could kind of draw a little line down the C, and that makes a 90 for 90 degrees. So if you are given some picture that looks like this, and then they tell you have a right angle, then angle X and angle Y will add to be 90 degrees. Supplementary angles are angles that add to 180 degrees. One way to remember that is you could stick a little 1 out front, cross that off, and put a top over there, and it forms 180 degrees. They might look something like this, and then you would have that X plus Y is equal to 180 degrees. Now, I gave you two adjacent angles that are complementary and supplementary. It could be any pair of angles. The only requirement is that they add to 90 or add to 180. You cannot assume angles are complementary or supplementary unless you are told so in the problem. So they need to either have marked this picture to have a right angle. The picture either needs to have angles that are adjacent forming a straight line to be supplementary, or they need to tell you in the problem. So you cannot assume angles are complementary without being told that there's some sort of 90 degree in the picture. So number one here. Two angles are complementary. Since they told us they're complementary, we know that they will add to 90. If one angle measures 4x plus 3 and the other measures 2x plus 21, find the measure of each angle. If you wanted to view this as a picture, you could draw yourself a right angle because you know they're complementary. Stick a ray coming out of there, and then you'd have 4x plus 3 here and 2x plus 21 here. You don't necessarily need to draw a picture for this one. Knowing they're complementary means that you can go ahead and add the two angles together and equal them to 90. Once you've done that, you can solve by combining your like terms. And then you can subtract 24 from both sides. So you get 6x is equal to 66. And then finally divide by 6 to both sides so that x is equal to 11. They did not ask you to find x, they asked you to find the measure of each angle. So to do that, you're going to take your 11 and plug it in for both angles. So you would do 4 times 11 plus 3 will be 47 degrees, and 2 times 11 plus 21 is 43 degrees. The last thing you can do to check is go ahead and add those two angles together and see if they equal not 180, they equal the 90 because it's complementary. As long as they equal 90, then you know that you've done it correct. A perpendicular bisector is just a segment that bisects a segment and is perpendicular to the segment. So when we look at this example 2 here, line DE is the perpendicular bisector of segment AC. If the length of AB is 4x plus 1 and AC is 3x plus 42, find the length of AB and the length of AC. So AC is this entire segment here, and AB is just this half. Since line DE is a perpendicular bisector, we know that it intersects segment AC at a right angle and cuts the segment AC in half. So then, if we want to find x, we can set up our equation. Since we know that AB is 4x plus 1, then we also know that BC is 4x plus 1, since it is the other half of the segment. So we can Either do 4x plus 1 plus 4x plus 1, or 2 times 4x plus 1, and that will equal 3x plus 42. We could then distribute, so we get 8x plus 2 is equal to 3x plus 42. We would then subtract the 3x, so we get 5x plus 2 equals to 42. Minusing the 2, we get 5x is equal to 40. Divide by 5, so we get that x is equal to 8. Once we know that x is equal to 8, we can plug 8 into 4x to find AB. So we know x is equal to 8. So then 4 times 8 is 32, plus 1 is 33. So the length of AB has to be equal to 33. Plugging into AC, we get 3 times 8 is 24, plus 42. So we get AC is equal to 66. If it hadn't been 66, then we would know that something was wrong since it needs to be twice AB. But it's always a good check to plug it into both segments to make sure. Vertical angles are each of the pairs of opposite angles made by two intersecting lines. So it's going to look something like you're going to have two intersecting lines, and the vertical angles will be the ones that are across from each other. So my two orange ones here are vertical, and the two blue ones are vertical. So both pairs are vertical, but and to each other, but not to the other, like the blue to the blue, the orange to the orange. One thing to note is that vertical angles are congruent. So since they are congruent, that means that the angles, their measures will be equal. So when we look at number 3, we see that AEC is vertical to DEB. Since they're vertical, we know that their measures are equal. So we can set up our equation to be 3x minus 6 is equal to 27. Solving that equation, we add 6 to both sides to get 3x is equal to 33. Dividing by 3, we get that x is equal to 11. They only wanted x, so we are good. If you wanted to double check yourself, you could just do 3 times 11, get 33, minus 6 is indeed 27. Looking at number 4, they tell us that line DE is the perpendicular bisector of segment AC. If the measure of angle DBF equals 2x plus 6, and the measure of angle CBF is equal to 2x, find the measure of angle DBF and the measure of angle CBF. This little dot should be right there. So labeling our picture, DBF, so that's DBF, that's that angle there, is 2x plus 6. And CBF, which is this angle right here, is 2x. Since they told us that it's the perpendicular bisector, that means that this angle is a right angle, and thus all of the angles are right angles around it because it's perpendicular. Bisecting means that it's cutting AC in half, but since we're talking about angles, we don't need that piece of information. We just need to know that these two angles form a right angle, which therefore makes them complementary. So to find x and the angle measures, I would do 2x plus 6 plus 2x is equal to 90. One way you can tell that those angles are not equal to each other is because they both have the same variable piece, 2x, but one of them has plus 6. So 2 times x cannot be equal to whatever 2 times x is plus 6. To solve this, we combine our like terms. So we get 4x plus 6 is equal to 90. Minusing 6 from both sides, we get that 4x is equal to 84. Dividing by 4, we get that x is equal to 21. Once we find x, we can plug back in to find the angles. So 2 times 21 plus 6 is equal to 48. And 2 times 21 is equal to 42. Double checking, 48 plus 42 is indeed 90. We know that we've done them right. So we can say the measure of angle DBF equals 48, and the measure of angle CBF is equal to 42. You guys try number 5. Since those two angles were equal to each other, since those two angles were vertical angles, then to solve it, you should set them equal to each other. Setting it equal and solving leaves you to an x of 38. Now give number 6 a try. Since we know that line DB bisects segment AC, then we know that AB is half of AC. So we can multiply AB by 2 and then equal that to 2x plus 18. Solving for x gets us to x equals 2. Plugging 2 back in for both AB and AC, we get that AB is 11 and AC is 22. Now give number 7 a try. Since they told you that the angles were complements of each other, that means that they add to 90 degrees. So adding the two angles together and setting them equal to 90 is how you set up your equation. Solving for x, you get that x is equal to 8, and then plugging 8 back in for x gets you each of the angles. A linear pair consists of two adjacent angles that form a line and are therefore supplementary. So they would look something like this. And that's angle 1 and angle 2 would be a linear pair, named such because they form a line. And remember that the measure of a straight line is 180 degrees, so it makes sense that the two adjacent angles would then add to 180 degrees. So if we look at this isn't numbered here, but finding the measure of angle 1 and finding the measure of angle 2. So since we know that angle 1 is 53 degrees, then finding angle 2, because this is a linear pair, we would just do 180 is equal to 53 plus x, minusing 53 from both sides. We get that x is equal to 127. So the measure of angle 2 is 127 degrees. This little blank should go over here. Looking at this one, we see that 3, 4, and 5 all make a linear pair, but because we have this little square here, we know that angle 3 is 90 degrees. Since angle 4 is 28 degrees, then we can either do 90 plus 28 plus x is equal to 180, or we can do 28 plus x is equal to 90. Because if angle 3 is 90 degrees, then the combo of 4 and 5 has to be 90 degrees, since 90 plus 90 would make 180. So that would give us that x is equal to 62. So the measure of angle 5 is 62 degrees. Taking a look at number 6, we see that angle 6 and angle 7 are a vertical pair. Since they're a vertical pair, we know that they are congruent. So if angle 6 is 44 degrees, then angle 7 also needs to be 44 degrees. We will talk about the rest of these examples tomorrow in class, and I will answer any other questions that you have. Make sure that you put any questions you have in the next question or be ready to ask them in class. I'll see you then. Have a great afternoon.